Welcome to this video on solving one-step equations. Let's begin. Before we can solve one-step equations, we need to answer the question, what is a variable? And the answer is that a variable is any symbol that's being used to represent a number. Oftentimes, you might be familiar with values, or symbols rather, such as x or y or z. Sometimes we use other letters like a or b. Sometimes mathematicians run out of the alphabet, and so then they steal symbols from the Greek alphabet. So you might see symbols like alpha or beta, pi, for example. You've probably seen that before. And sometimes mathematicians just make up their own symbols altogether. Honestly, you could even use emojis. You could use like a smiley face or a sad face to represent a number. The point is that it's a symbol. Again, we go to the alphabet just for sheer convenience, but it really doesn't matter what the symbol is as long as we understand that it's representing a variable. So why do we use variables? Well, there are times that we have information about a number, but we don't quite yet know what that number itself is. So variables act as placeholders for numbers. So let's start with this basic example. We have x plus 5 equals 12. So one thing I always encourage my students to do when they're doing these problems is I encourage them to draw a vertical line through the equal sign. And that way you can keep the two sides of the equation separate. Because remember, the rule when solving equations is whatever you do to one side, you must do to the other. Okay? The other thing to keep in mind is that our overarching goal is always to isolate the variable. So anytime I'm trying to solve an equation, I'm always trying to get the variable all by itself on one side of the equation. So right now I have x over here. However, x is not by itself. X has a plus 5 next to it. So what I need to do is I need to undo the plus 5. And in order to do that, I have to use what's called the inverse operation. So, for example, right, if I gave you $5, how would I undo that? Well, I would undo giving you $5 by taking $5 away. So the opposite of a plus 5 is quite simply a minus 5. Now notice I have this vertical line to help me keep track of the two sides of the equation. So I have to minus 5 on the left side, and I also have to subtract 5 on the right side. When I do that, I can see that these 5's cancel out. We just bring down our x, and 12 minus 5 is 7. So the final answer to this problem is that x equals 7. Remember, you can always check your work by putting that number back into the equation. Does 7 plus 5 equal 12? Is that true? Absolutely. 7 plus 5 is 12, and 12 equals 12. So you can always check your work using mental math or a calculator to verify your answer. Let's do another example. Now we have x minus 2 equals 10. Again, the first thing I always do is I draw a vertical line so I don't get those two sides confused. So right now, remember, my goal is to always isolate my variable. I always want to get my variable all by itself on one side. But right now, x is not by itself. In fact, it has a minus 2 next to it. So how do I do minus 2? How do I undo that? Well, I have to add 2. Minus 2 plus 2 is going to give me 0. And remember, whatever you do to one side of the equation, you have to do to the other. You have to do it to both sides. So these cancel out, and we get x equals 12. Okay, so that is our final answer, x equals 12. And again, we can always check our work by plugging that value into the original equation and showing that that is true. 12 minus 2 equals 10. Well, absolutely, 12 minus 2 is 10. 10 equals 10, it checks out. So that is correct. So let's see if we can summarize this process. So as you've noticed so far, we've undone, right, or we've gotten rid of addition by using subtraction. Addition and subtraction are what are called inverse functions. Likewise, we can undo subtraction by using addition. Again, addition and subtraction are inverse functions. Well, what about multiplication and division? They are also inverse functions of each other. So, in other words, to undo multiplication, I need to divide, and to undo division, I need to multiply. So now we have this set of inverse operations, we can continue on looking at some different one-step equations. So in this problem, we have 3x equals 12. So the first thing I'm going to do is ask myself, well, what does 3x mean? Well, what it means is 3 times x. So once again, I have to ask myself, how do I undo multiplication? What is the inverse operation of multiplication? Okay, and the answer, hopefully you remember from this chart, is that to undo multiplying by 3, I have to divide by 3. And again, I can only, if I divide by 3 on one side, I also have to divide by 3 on the other side in order to keep my equation balanced. So 12 divided by 3 is 4. So that's my final answer. Okay, and again, I can check myself by putting 4 back into the equation. Is 3 times 4 equal to 12? Is that true? And it is, absolutely. So I can check my work and I can walk away knowing that I did this problem correctly. So notice down here in the corner, I wrote myself a note, right? And this is the question that I'm always asking. I'm saying, what operation is being done to my variable and how do I undo that operation? Okay, and if you can answer these questions, you can solve any one-step equation. Let's keep going. Now we have negative 5x equals 25. Again, I'm going to ask myself, what operation is being done to the variable? So if you look at negative 5x, well, what does that mean? Well, that literally means negative 5 times x. Well, how do I undo multiplying by negative 5? And as you can see here, we undo multiplying by dividing by the exact same number. So let's see if we can try that and see if it works. Okay, so one second, let me move this. Okay, there we go. So I'm going to divide both sides by negative 5, divide by negative 5, divide by negative 5. Okay, these cancel out. Negative 5 divided by negative 5 is positive 1. So I could write 1x equals negative 5, or I could just write x equals negative 5. Okay? So that is my final answer. Again, I can check myself. Go back to the original equation, which is negative 5x equals 25. Okay? And find out, is negative 5 times negative 5, does that give us positive 25? You can use your calculator to check this. And it absolutely does. We get 25 equals 25. So we have checked our work and it checks out. It is correct. So again, we've decided that multiplication was being done in this particular problem, and we used division, right, to undo our multiplication. All right, let's keep going. What about this problem here? So we have negative 12x equals negative 6. So again, what is being done to our variable? Well, negative 12x means negative 12 times x. How do we undo multiplication? Again, we divide. So we are going to have to divide both sides by negative 12. Okay, and again, you can always draw that vertical line so that you keep your sides, the two sides, straight. Okay, so the negative 12s go away, they cancel out. Then we have negative 6 divided by negative 12. Well, what is that? Well, it's a fraction that we can reduce. In fact, if I divide the top by negative 6 and the bottom by negative 6, then negative 6 over negative 12 reduces to positive 1/2. So my final answer is that x is equal to 1/2. Let's check our math on that. Okay, so I have negative 12 times 1/2 equals negative 6. Type that into your calculator or do it in your head, and it is absolutely true. Negative 6 equals negative 6, so our answer is correct. So be careful with the fractions. Sometimes people do 6 over 12 and they either drop a sign, right, and they forget that it should be positive because there's two negatives there. Negative 6 divided by negative 12 is a positive number, and sometimes people flip it and get 2 instead of 1/2. So be careful with that as well. Okay, what about this one? X divided by 4 equals 3. So again, we have to ask ourselves, what is being done to this problem? Or what is being done to our variable? Well, right now, we are dividing. We're dividing by 4. So how do we undo division? Well, simply, we need to multiply. Okay, again, I'm going to draw my vertical line so I can keep my two sides straight. So I am going to multiply this side by 4, and I'm going to multiply this side by 4. Sometimes this confuses students, so if it's helpful, you can rewrite it as 4 over 1, if that helps you. Okay, this gives me 1x, or x over 1, gives me 3 times 4 is 12, or 12 over 1. So our final answer, oops, sorry about that, our final answer is x equals 12. Again, we can check our work. 12 divided by 4 equals 3. Okay, again, that checks out because 3 is equal to 3. All right, how about this problem? X divided by -2 equals -3. Again, the first question we ask ourselves is, what is being done to our variable? Right now, we are dividing by -2, and we undo division by multiplying by the exact same number. So what I need to do, bring this equation down here so I have more room. I need to multiply both sides by -2. And again, if it makes you feel more comfortable, you can rewrite it as -2 over 1. It's the same thing. So these cancel out. We get x, or x over 1. -3 times -2, watch your signs, is +6. Again, we can go back and we can check our math. So if I type in 6 divided by -2 into my calculator, it does in fact give me -3. So it checks out, and that is the correct answer. Let's look at this next example. So we have 2 equals 5 plus x. You might notice that this time x is on the right-hand side, not the left-hand side. It really doesn't matter where x appears in our equation because we're always going to be asking ourselves this question: what is being done to the variable and how do we undo it? So hopefully we can all agree that 5 is being added to x. So what is being done is plus 5, and the way we undo that is by subtracting 5. So again, I'm going to draw my vertical line so I don't get my two sides of my equation confused. I'm then going to subtract 5 from both sides of my equation. 2 minus 5 is -3. 5 minus 5 is 0. You could write 0 plus x, or you can just say that x is equal to -3, or -3 is equal to x. Notice that saying that -3 is equal to x is exactly the same as saying x equals -3. Both of these are true and correct. And as before, we can still check our work. We have 2 equals 5 plus -3. Is 5 plus -3 equal to? Absolutely. So this checks out, and our answer is correct. Let's do another example. Now we have -2 plus x equals 7. So again, what is happening to our variable and how do we undo it? So we're adding -2. So what we would need to do is to subtract a -2. However, let's think about this. Minus a negative is the same as plus a positive. So what we're really going to end up doing is we're going to add 2 to both sides of our equation in order to cancel out. So I have a -2 and a +2. That gives me 0. 7 plus 2 equals 9. So we have x equals 9. Again, I can go back to my original equation, and I can put the 9 in there and check and make sure that this equation holds true. So again, -2 plus 9, you can use your calculator or do it in your head. You get 7 equals 7, so this checks out.